Okay, now we're going to look at the extend the special right triangles, and we're going to show the proofs. This is not absolutely required for the regular geometry classes, but for our honors geometry classes, hint, 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 this would make a fantastic little quiz to come in one day and give you a blank sheet of paper that just said, hey, prove the two special right triangles and their relationships. From scratch, from memory. It's something you need to know how to do just to get things done. Now, what we're going to do is we've got a 45, 45, 90 degree triangle, and we've got it drawn here, and each side is x. Okay? And so what we want to do is we want to prove what the relationship between these three sides is. So we're just going to simply use, by using PT, good old Pythagorean theorem, we're going to find C. So C squared we know equals A squared plus B squared. Well, if this equals A and this equals B, let's go. C squared equals X squared plus B, not B. B is X, so we're going to see you have X squared. Now, C squared equals, well, there's two of them, 2x squared. Now, what we've always said is we're not interested in C squared. We're interested in what? Let's bring it up here. C squared equals 2x squared. We're going to take the square root of each side. If we take the square root of C squared, we're going to have C equals the square root of 2x squared. Well, what's the square root of x squared? It's x. So C equals x times the square root of 2. Okay? What are those relationships? Well, across from the 45 degree angle, we have x. Across from the 45 degree angle, we have x. Across from the 90, if that's x, we have this. And you have your relationship. C equals x square root 2. Okay? That's number one. Pretty simple to do. Here's a 30, 60, 90 degree triangle, and we're going to prove it. Now, in order to prove it, we need an equilateral triangle. Okay? All the angles are 60 degrees, all the sides are equal. What we're going to do is we're going to drop an altitude from one of those vertices, and we're going to cut the other side in half, and we're going to name one half of that side x. Well, if one half of that side is x, this right here is 2x, so we're going to call this 2x. Okay? This right here is going to be A. This is going to be B. No, that's not B. That's what? That's across from the 90 degree angle, so this is C, and we sure would like to find B. Alright? So what's B squared equal? B squared equals C squared minus A squared. So B squared equals what's C squared? 2x squared, what's A? Plus x squared. So let's do it. Equals, square everything inside. Square the 2, that's 4x squared plus, well, that's got to be a minus, doesn't it? Because we're, yeah, minus. Let's get this thing right here. Squared. Well, 4x squared minus x squared is 3x squared. And again, we're not interested in b squared, we're interested in b. So the square root of b squared is b, and we have to take the square root of 3x squared. What is the square root of x squared? It's x. So b equals x square roots of 3. Okay, so this is x square roots of 3. So across from the 30 degree angle is your x. across from the 60-degree angle would be x times the square root of 3, and across from your 90-degree angle is 2x. Okay? Very simple proofs. All we have to do is simply look at it, and it's pretty well makes itself known. But it'd be a good thing for honor students. You need to know how to do that. Be a nice little quiz for us one day.